Let's do number 1.66 on page 31. So notice the three little balls. That means this is one of the, on a level of 1 to 3, it's a number 3 difficulty. So it's usually a multiple-step problem. It has a little trick to it. On a training flight, a student pilot flies from Lincoln, Nebraska to Clarinda, Iowa, then to St. Joseph, Missouri, and then back, and then to Manhattan, Kansas. The directions are shown relative to north. 0 is north, 90 is east, 180 is south, and 270 is west. Use the methods of components to find A, the distance she has to fly from Manhattan to get back, and B, the direction she must fly relative to north to get there. So here are the vectors. We see she starts off here, and notice the strange degree signs. We actually have 0 degrees normally and east. They have 0 degrees north. So she's going from the north around like this. Notice how it's counterclockwise. We normally start at 0 and go clockwise. 0, 90, 180, 270. Here, they start from 0, 90, 180, 270. So their system is counterclockwise. Our system is clockwise, and they also shifted the 0 point. So what we're going to do, what I suggest is just to convert everything back to our normal system. Now you can do it several ways. You can use their system, but because you guys are just starting out, it's a very good exercise for us to change the system back to our normal system and then do it, the problem like we normally would do. So the first vector, and I'm going to write each one down, so I know it wasn't that much time for you to write them down, was 147 kilometers at 85 degrees. And that 85 degrees, I'm going to put east of north. That's in our coordinate system, just so that we're no. But in their coordinate system, it's just 85 degrees because their 0 is on the plus 90. So this is what it looks like. And 85, this is how they're measuring 85 degrees. Now what we're going to do is change that into our coordinate system, where we have 0 here and we have 90 up here. So 180. So what we want to do is measure this angle. Now this is a fairly easy one. 85, there's 90, so 85 minus 90, so it's 5 degrees. So we're changing it from 147 at 85 to 147 kilometers at 5 degrees. Okay, so this is the vector we're going to use for the first. The first vector is going to transform to that one. So what about the second vector? This one, as you see, is probably the trickier one. But once you get used to like the coordinate system, it's not so bad. That vector is going down like this. Now, how do they measure their angle? Their vector is 106 kilometers at 167 degrees. All right, so their 167 is measured here. So this is 167 degrees here. Now, what do we want to measure? Well, here is our axis, right, or 0 degrees. We always measure from the plus 0, so we want to measure this angle. So I want you to figure out a little bit. Think about how you do that. So we can figure out what this angle is pretty easily and subtract it off 360, right? Or, I mean, we can do several things. We can take this 180, 360 minus 167. There's a lot of different things we can do. But what we're going to do is first find out what this angle is. And that is 180 minus 167. So actually, it's not. This is 180 minus 167. Gotta be careful about that. So what is 180 minus 167? Now, if we wanted this one, however, we could do it. So this would be 180 minus 167 degrees. This angle would be what? This would be 167 degrees minus 90 degrees. And this is probably the better one to use anyway, because then we can just subtract whatever this is off of 360 to get our final answer. So again, this one would be 180 minus 167. This angle would be 167 minus 90. You see that? And to get the angle that we want from our coordinate system, from the 0 all the way to this point, once we know what this is, and you can see what 167 minus 90 is, it's going to be 77, right? Then all we have to do is take 360 minus 77 to get our result. And you should go ahead and subtract that. We would get 167 kilometers at, what would it be? 360 minus 77. You should have got 283. Okay, so now our third one. Now what is our third one? It is 166 kilometers at 235 degrees. And again, that's west of north. No, that's east of north. So again, all of these things are east of north. Remember, all of these things, because their coordinate system starts at north. So let me just draw it. So this one is going in this direction right here. So remember, the 235 is this angle right here. This is their angle. The angle that the pilot is using. So that's their north. Now, we, of course, have 0 degrees at east, so what we want is this angle. So how are we going to do that? Again, it's a little figuring it out. It's 180 plus whatever this thing is. So how would you think you'd do that out? Well, I mean, like before, you can do it several ways. 235, you can figure out what 270 minus 235 is, and then you can figure out what this thing is. You can take 235 minus 280, 180, right? Then you can figure out what this one is. So let me do that again. So this angle right here, if we wanted this angle, that would be 235 minus 180. If we wanted this angle, it would be 270 minus 235, right? 270 minus 235. So whichever way you do it, this one's probably a little easier to do, because once we have this one, then we just add that to 180. So you got that? So whatever you do it, whichever way you do it, you should come up with the same amount, and you should come up with, I'll let you have a few more seconds to calculate it. So again, 270 minus 235, add 180. You should get 215 degrees. So now, there are our 3 angles. Oops. Now that we got to this point, we're going to proceed exactly like we did in class for the other 3 vectors. We're going to find the x components, then add all the x components. So the only trick to this one, it does have 3 little balls on it. The trick to it is just the coordinate systems are shifted. But there's no preferential coordinate systems. There's no absolute coordinate systems. You can move the x-axis to wherever you want. So in this case, they have the x-axis due north. So why don't we go ahead and write down our x components. For this one, it would be v. We're going to call this vx. So v1s, we're going to call this v1. So v1x would be what? v1 times cosine of the angle. So this angle is 5 degrees. And v1 would be 147, right? So this is 147 kilometers. And v1y would be 147 kilometers times sine of 5 degrees. Okay, so take your calculator out, make sure it's in degrees, and go ahead and do these 2. All right, 147 times cosine of 5. So you should have gotten 146.4 kilometers. And for the second one, you should have gotten 12.8. Now, does that seem reasonable? One's much smaller than the other one. Well, for 5 degrees, the y is really tiny, and the x is going to be pretty close to what the actual value is. So yes, you see how they sound logical. Now remember, sine and cosine are not linear, but the y should be much smaller than the x, and that's what we see. All right, so now we have our second one. Now this one, they should be a little bit more equal, although the y now looks like it's going to be a little bit bigger than the well, it's kind of hard to tell the way I drew it actually. But no, yeah. So number 2, we have 106, V2x. Okay, V2x is equal to 106 kilometers times cosine of 283. And we have V2y is 106 kilometers times sine of 283. So go ahead and calculate those out. And then, of course, we have the last one. We have V3x and V3y. And what I'm going to do is I'm going to stop it, and then I'm going to start another video to do the last part of it.